This demonstration will build a data access layer that is accessible as a bindable data object in application development environments like Visual Studio and business intelligence applications like SQL Server Reporting Services and Crystal Reports. As well, data return can be accessed with LINQ, Microsoft's language integrated query technology. After creating the DAL, we will show you how to wrap the whole thing in RESTful Web Services. Representational State Transfer, or REST Web Services, are simpler to implement than SOAP and WSDL-based web services and have been adopted by major players on the Internet, like Amazon and Google. Rather than write code for everything, we will use the mvLynx managed provider's data objects to generate our strongly typed dataset. This technique can be used with any standard managed provider, such as SQL Server or Oracle, to do the same thing. They all have a data adapter, connection, and command object. The mvLynx managed provider just happens to connect to MultiValue data of any flavor. A strongly typed dataset allows any data-aware control to know what it needs to do with it. For example, dates are processed as .NET dates, and decimals and integers are properly justified, and so on. Also, when we build our REST wrapper, the XML generated can be structured properly. The mvLynx managed provider makes accessing MultiValue data a few simple steps. View our demonstration of the mvLynx Direct Designer to see how we identify which MultiValue files and attributes we want made available in our development environment. This is an example of an item from our sales order file. Note the multi and subvalued data. We will build our data access layer in Visual Basic, but it's just as easy to use C# if you prefer. A strongly typed dataset structures the MultiValue data as a multi-table dataset, with the multi-value and subvalue data automatically linked to the single value data. The tables not only contain the links, but provide information about the multi or subvalue position in the original file. The class we create will be what external environments see. It will contain the code that does the work, along with the select and update methods we will be exposing. We now add the imports or classes we will be using. Of course, we add FusionWare's mvLynx managed provider libraries, but other than the standard list, we need to add the system component model. Almost everything in system component model is used to make things easier to use when developing, for example, to make it easier to integrate with Visual Studio or third-party tools. System component model data object is used so that when you use, let's say, an object data source, it will put your class in the drop-down thinking, aha, this thing provides data. This becomes mostly useful if you work in a team and you make the business object, and someone else has to use it. They'll be much more efficient at finding it in the Visual Studio wizards and configuring their own object data sources correctly. We wrap our overall class in the system component model data object, and we'll also wrap our select and update methods later. The constants we set up are to preload the connection string. We will use the same one we did with the connection object. When we create a data access layer, each class is commonly very targeted to a particular data source and type of data. Whenever we retrieve data from the MultiValue database, we use the same Visual Basic function. The getSalesOrders function allows us to build a common bit of code to talk to the database and simplifies greatly our select methods. Whether we access a MultiValue database or a relational database like SQL Server, this code wouldn't change much because the mvLynx managed provider strictly adheres to managed provider standards. In fact, if we wanted to repurpose this code to SQL Server, we would just have to change the type declarations for the adapter, connection, and command objects, and we would be done. Basically what this code does is creates a command and assigns it whatever command is passed in, then sets the command's connection using the connection string constant we created earlier, and then lastly uses the adapter to fill a dataset full of data and metadata from our MultiValue file. So that the data access layer class can be accessed in a data object way, we need to create and identify functions as data object method attributes. The first one we will create is a select type method and will simply retrieve the entire sales order file if called. Our sales order file contains 10,000 items. We're also going to set this first method to be the default select method. Now we will create the select method we will more commonly use and is probably more reflective of data access layers in production use. The data access layer should focus the interaction with the database so that the things we really need to do are simple and fast. In this case, we want a method that retrieves a single sales order by its sales order number, or ID. We could create a select method that returns a list of orders based on some search criteria, like the customer name also. To demonstrate the flexibility of the mvLynx managed provider, we will create an update method that will change the urgency of the order by calling a MultiValue BASIC program and passing in the item ID. The BASIC program will toggle attribute 3, the urgent flag, on and off each time it is called. The BASIC program will be displayed shortly in the top right corner. FusionWare provides some basic subroutines that can be called to return error conditions, process past parameters, and even generate metadata in the format .NET is happy with. Instead of using the adapter to fill the dataset, we just call the command's execute non-query method, and no results are expected or required. And that's it for our bindable data access layer, or DAL. The DAL provides methods to retrieve data from the sales order file and also to update that same file. To the consumer of this DAL, little or nothing need be known about where the data ultimately comes from. It comes from the DAL, is all they need to know. Now, to make this DAL consumable by any number of unknown clients that could be on any platform, we will wrap it up in web services. Another video we have done showed SOAP and WSDL-based web services. This one will demonstrate RESTful Web Services. REST has gained wide adoption, including by companies such as Amazon and Google. To do this, we're going to add another class library to our solution. To show that languages don't really matter, we will use C# to build our REST class library. We add the necessary managed assemblies so that our class library can be seen in the context of the system service model. Just as with the DAL, we need to wrap our class and methods using the service model, which is part of the Windows Communication Foundation, or WCF. The terminology for web services is consistent. First we need to indicate the service contract, and then the operation contract. The operation contract identifies what methods are available and how they are accessed. Within the operation contract, the URI template identifies the path to call the web service. In our example, we use the routing class to store the URI template value for each web service method we will call. For example, for the web service consumer to call the getSalesOrderByOrderNumber method, a webGet method, the path to the web service server must be used along with the /SalesOrder followed by another slash and then the actual sales order number or item ID in our case that will be used. This method of calling a web service is much simpler than using a WSDL file and constructing a complex XML package that will execute the web service. In our example, you can easily call and test the web service using a simple browser. Making your data available through REST's web services opens up lots of doors as far as providing information in a timely manner to the people that need it whenever they need it and wherever they need it. Almost anything can consume a RESTful web service. In another video, we will show a Windows Phone 7 device calling both web services we are exposing here. But you aren't limited to the Microsoft stack. You could just as easily be using an Apple iOS device like iPhone or iPad, or perhaps an Android phone or tablet. Maybe another company will be doing business with you and would like to submit purchase orders through a web service. You can expand the reach and, just as importantly, the value of your existing application without incurring the large costs associated with migration from your existing MultiValue line of business application. The REST standard requires that commands that change existing data use the HTTP POST method, so we will follow that convention here by using the web invoke attribute. The next piece of the puzzle is to add a service behavior. The service behavior class contains the actual methods that will be called. In our case, we will have two methods, one to retrieve a specific order by the order number, and the other to toggle the urgent flag. In both cases, they will simply call the sales order DAL we have previously created. In this part of creating our REST web service, we consume the data access layer in exactly the same way we would if we were just creating an application that would display orders. The only major difference is we are exposing these methods through the Microsoft Communication Foundation as a web service. The first method we will add is the method that will retrieve a single sales order by passing to the DAL a sales order number. The DAL will return to us a dataset, which is a Microsoft construct and therefore cannot be returned as a result from a web service. To resolve this, we will convert the dataset to XML first. The XML will be returned as a result of the web service call. The XML is based on the dataset, so all field names are used as tags within the XML result. The second method is our update method and will ultimately execute a basic program on the MultiValue database that will toggle the urgent flag on the identified sales order. The consumer of this web service will be notified if the web service fails by returning an XML element containing a 0 rather than a 1 for success. Other than that, the code is not complex at all. The only thing left to do is create a website that will host our web services. We will begin by adding a new website to our solution. The website must reference our sales order REST project so that we can route the service's call to it. We are building these web services using Microsoft's Visual Studio 2010. There is no reason all of this functionality could not be developed using another development stack like Java. FusionWare's mvLynx Java Data Adapter provides much the same functionality as our mvLynx managed provider. In fact, they both share the same back end on the MultiValue system. Any basic programs or data mappings you create specifically for the managed provider will work unchanged in our Java Data Adapter. Develop how you like using the tools you prefer. To provide the location on our website where the web service will be called, we will add an AJAX-enabled WCF service. We will shortly point this at the REST class library we just created. Because we will be using the REST class library rather than the code behind our service, we can remove the VB code behind file. Once we have done this, we need to modify the created service file to point to our REST service model class. We change the service attribute and add a factory attribute so the service knows how to execute things. After setting our service file to be our startup page and our website to be the startup project, we are ready to test things. After allowing the debugger to be turned on, we can start executing our web service. Calling the web service is as simple as combining the URL for the web service with the URI template we created in our routing class inside the REST class. We can then call our web service. And yes, it is as easy as it looks. Our mvLynx managed provider is designed to work across all .NET technologies. You can build a web service application that exposes MultiValue data as REST web services one day. The next you can build a WPF application in C#, or an ASP.NET application, or even a transformation with SQL Server integration services, using the same connections, methods, and tools. Thank you for viewing our demonstration showing MultiValue data served up through RESTful Web Services. Using the FusionWare mvLynx managed provider, no special tools were required.